Guess it's about time to get started. And hello, everybody, again. For the top news story, Dyson reveals its big bet, robots. Will this be the start of a big move for robots as a household convenience and work saver? In coronavirus story, in breakthrough infections, vaccination reduces the risk of long COVID by merely 15%. For technology, in DeepMind's Gato AI, is DeepMind's Gato AI really a human-level intelligence breakthrough? DeepMind can do 600 different tasks, and some of it call it generalist AI. In the environment, the world's largest vats for growing no-kill meat to be built in the US. These are 4-story bioreactors and will produce 13,000 tons of chicken and beef each year. And in materials, a long hypothesized next generation wonder material is created. As Richard says, are you tired of hearing about graphene? Now there's graphene. I'm not sure how that's pronounced. In space, the Webb telescope is nearly set to explore the solar system. In biology, researchers find another layer to the code of life. In humans, there's new research shows that there's no evidence of structural brain change with short-term mindfulness training. Nevertheless, Richard does think that mindfulness changes the brain. So we'll talk about it.
They need do it for more than 8 weeks.
In health, the aging clocks aim to predict how long you'll live. How accurate do you think they are? So that's what we'll talk about today. Now, Richard, what's this in our top story? That Dyson reveals its big bet on robots.
Now, we don't hear much about Dyson in the US. It's a UK company, but like companies that we hear a lot about, Dyson is really a privately owned, fairly big company. And what they have announced is that they are placing an enormous bet on producing robots that are capable of household chores. Their goal for the rollout of their product line is 2030, so they're not going to do it today, but it's a big plan. And Wednesday, they published photographs of some robot arms being used in a household setting to kind of make a teaser. Let me show you what they had. Here is a robot arm picking up a dish from a tray. There's a different robot arm cleaning off your chair. And here is a robot hand picking up a soft toy. So those are, they think, examples of the kind of thing that they might be able to do. And while this doesn't sound like a big achievement, robots still struggle with many actions that are easy for humans, such as grasping fragile objects or dealing with unfamiliar obstacles. Solving these problems, Dyson thinks, will create new products for new markets for the products of the company. As part of their effort, they've announced that they want to build UK's biggest robotics research facility. And in fact, in the last year, they've hired 2,000 people. 1,000 of them are engineers. So these are not cheap hires. They've also said in the next 5 years they want to hire another 700 robotics engineers. So they really are spending money on the research and development side to move forward with this. And they say altogether that they're going to spend almost 3 billion pounds, but from by 2025 to get in the game, and that's a lot of spending. And they're going to launch new products, including robots, and they're going to do something with batteries. It's not clear what they are going to do. And, robots are presently used a lot, but they are in control situations like factories where you know the environment and you know what's going on around them. And other than those Roomba like vacuum cleaners, robots haven't made it into the home because it's still too chaotic and unpredictable an environment. But Dyson is going into this in a big way, and Jack Dyson, the son of the founder, says, quote, "This is a big bet on future robotic technology that will drive research across the whole of Dyson." So they're the first big company that has made this kind of a announcement, and I look forward to seeing what happens.
Any thoughts?
Dyson has used good business judgment. He started out with a big EV automobile movement, and
Uh-huh.
then decided it just didn't work.
Right, it wasn't going to be profitable enough, and he stopped. Yes, it
Yeah,
makes me think he must think the robot business is going to make him rolling in dough.
well, Elon Musk thinks so too.
Well,
I wonder a little bit about if we use things, is there something that we lose? Talking to Paul Bennett, who some of us know, when he was in the Solomon Islands many years ago, some young Solomon Islanders in their bare feet would go around grasping rocks and grasping trees, where their toes were the same as our hands are for being able to do things independently. Over time, presumably we always could do that, but now we've lost the ability. I can't do anything with my toes. And I wonder if robots will do a lot of things for me in my house, what other things I might lose.
well, without being the robots, imagine. I remember when I was a kid at my grandmother's house. She had a washing machine that was electric, but it still had one of those rollers that you would push the clothes through. And she ended up getting a new washing machine with its robot like dryer thing, and she lost her ability to turn the crank. So we might lose it, but I don't know. Certainly, the technology brings these changes and brings deep changes, like you're talking about, Fred. So this will be another round of it. For me, I do not look forward to one part of it. Here they had a robot dishwasher, and enjoy washing the dishes as a part of my mindfulness exercises every day, and it's one of the nicest parts of my day. And so to
What
have
if what if what if robots could do sex so much better than we can?
Well, already I think they can. There's a big market for that. We haven't talked about it, but
I've never
it
tried it.
it changes the ethical questions about sex too when you're dealing with the sex robots.
So do they create babies actually?
So far, not yet. Just give them time and there will be, you can have the sperm collection attachment.
Right.
They probably wouldn't have any problem with erections.
No. They have a permanent one.
For our coronavirus story, apparently vaccination reduces the risk of long COVID by only 15%. Tell us about that.
I was not happy to read this story. This is, they did a careful study of more than 30,000 people who went through the Veterans Care in the US. And they looked at them within different groups. They're and one of the things that they see is that it looks like vaccination before infection confers only a little protection for long COVID. And so this means that just relying to mitigate the problem of long COVID, just vaccination is not going to do it. What they found in the study was that prior vaccination reduced the risk of death by about a third. So that is a significant benefit, but it reduced the long COVID only by about 15%. So long COVID still remains a substantial risk. And it means that though vaccination reduces the risk of death, but it doesn't solve the public health and long-term health issues that we've got to deal with. And we still have to continue to consider such things as social distancing and wearing good masks.
And presumably, Richard, though, vaccination does reduce the risk of infection. Is that not correct?
That is what I understand. That is not talked about in this study.
Yeah. Any thoughts?
I noticed that even the study says that their research is limited due to it being mostly older males and
Right.
white.
And
Yeah.
it was also pre-Omicron.
Yes. So there's a lot
As
to
Chad
suspect.
knows, and as Chad knows, there aren't many of us older white males. Is that right? So it's not very relevant, eh?
It might be relevant to us, but it's not a relevant study to the whole population.
For our children
Yeah.
and their children. But it's a data point, and the data point says to me that vaccination alone is not going to give us the mitigation that we need in terms of the world's health.
I'm starting to look for my 5th booster.
Okay, well, I think what I read makes me think you should plan a booster about every 4 months.
I think you're right.
Okay. And in the US, you can just do that now with no problems?
There was a time when some people were saying we shouldn't get boosters because most of the third world can't get anything at all. We no longer think that our getting boosters reduces the possibility for other people. Is that correct?
I don't know.
All right, I haven't heard that argument for a while. Maybe it's like, because the people halfway around the world don't have any apples. Can I eat this apple right in front of me? I think I can. I don't think it's going to make any difference.
Well, if you're not sure whether you can do it, we should perhaps ask DeepMind.
That's
Now,
right.
what is this about DeepMind doing so many tasks, and we call it a generalist AI? What is that?
Well, DeepMind has released its latest version, and its latest version is it calls it a generalist AI, and it's called Gato. We know what Gato means. And it can do things like play Atari games and accurately caption images and chat naturally with a human being. And it can do 600 other things. And so uh, DeepMind talks about it as a generalist AI, but is it truly intelligent? Does it have artificial general intelligence, or is it just a pumped up AI model with more tricks up its sleeve? And uh, the individual AI models have limited specific abilities. They're good at one thing, but not good at another thing. And this artificial general intelligence, AGI, is a term that is used as a model for uh, a system that can learn any intellectual task that a human being can. In other words, systems that can flexibly, resourcefully solve problems that they haven't seen before and do it in a reliable way. That's what we can do. So that's what the goal is. And uh, there are a number of opinions about DeepMind's Gato, uh, of course, and the chief AI scientist at Facebook's owner Meta says uh, there's no such thing because even humans are specialized. So humans aren't AGI either, he says, and we still don't have a learning paradigm that allows machines to learn how the world works, like humans and many non-humans, babies do. And he says the solution is not just around the corner. We have a number of obstacles to clear, and we don't know how. So that's the chief AI scientist at Meta, and he might know about the problem. Now, one of the ways they've been making headway in the current AI research is a matter of scale, putting bigger computers in bigger sample sets, more data and more computer power training these bigger models. And so far, they don't see any sign that this brute force approach is not going to keep providing more capable AI. But still, a lot of the researchers don't think that this approach will lead to consciousness or general AI. It's just applying more brute force to the problem. Now, one of the supporters, a guy at DeepMind, tweeted that he says the game is over when Gato was released, suggesting that AGI was now just a matter of making the models bigger and more efficient and getting more training data in. Competitive viewpoints point out that Gatto was trained to do each and every one of the 600 tasks that it can do. And it's like a collection of parlor tricks, he puts it. And that doesn't mean that AGI is anywhere near. And even DeepMind's own scientists are skeptical to the claim of Gatto as nearing artificial general intelligence. They say they genuinely don't understand why people are so excited about Gato. They took a bunch of independently trained apps and then put them all together into a big apps in a big single network, and that doesn't seem surprising. It's just more brute force. And they are saying that these models are creating surprisingly good results, and maybe if you continue to train them, somehow it'll learn about the world and somehow get AGI. But they still don't think so. There still have to be other innovations, they believe, that fill in some of the gaps that they currently have, like with creativity and interactive learning, which seem pretty basic to this artificial general intelligence. So to me, it sounds like Gato is just applying brute force power to the problem. And I think the solution in doing it is going to happen when somebody figures out some clever new way to approach it. That's one of the ways that you see technical process progress happens, when some guy figures out something and suddenly you can do it 10 or 50 or 100 times better than you could do it yesterday. And I think that's the kind of thing that's going to happen that makes AGI possible.
Any thoughts?
I don't know. You know, I have this Google thing on my desk here, and I could ask it, but you know, I hardly ever use it. I mean, because the information that it provides is typically, not useful.
Well, I think the Google thing on your desk is a not quite the deep mind power that they were talking about here.
Well, I know, but still, it's supposed to have access to Google's database.
Uh-huh.
You're talking about Alexa.
Well, this is called Hey Google, I call it.
The Google
It,
version.
Okay. Well, you have to ask the right question. You can't just.
Well,
Would you like me to do that?
that's true.
That's
It's just
right.
asking me now because I mentioned this name and it came to life. But,
I realized a few years ago that in this generation, one profession could be someone who could ask the right question of Google to give you the answer you need. Because if you ask too general a question, you get a million responses and it's
Right.
not useful. And so what you really would like is just to get one response and the best answer to what you meant when you asked the question. But they're
Richard,
a long way.
I have a general question then. What people have sometimes talked about quantity and quality.
Uh-huh.
There are some people who would say there is no such thing as different qualities. If you give it enough quantity, it becomes a new quality. And the question in here is, if you have enough tasks, is that in fact a generalist thing? Or is it substantially different to do a general thing rather than having more and more tasks? I don't think I know the answer to that.
Well, to me, it seems like part of the answer that some of them said is the real artificial general intelligence is the ability to look at something new, a new problem, and be able to figure it out. And I think until they reach that point, then it's still like what we see here, a brute force kind of approach. And, so I think we're a long way from there. For me, also, the problem with quality versus quantity is like with the search. When I ask a question, I don't want to have 4 million answers because I will never get to the first of them. It's rare when I do a search that I click to the second page of results, and even rarer I click to the third page, and that's about 20 per page, and that's a way short of 4 million. That's why I just want the answer.
That's not easy because the purpose of Google is to make money. And when you ask a question, they try to figure out what can they possibly sell you.
That's right. That's right.
So they give you a whole bunch of answers, not in your interest. Do you remember Google way back? You could say, ask a question and say, not including this and this and this. You cannot do that anymore.
I didn't realize. I thought they still had the way you could write your questions and add internal expressions to exclude things. I think I'll have to look at that. I thought you could.
I haven't seen it.
Oh, again, they don't make it easy within terms of the interface, but I thought if you knew the code, you could still put that in your expression.
I think you probably can still do that, but there are some, really good capabilities that they had for tight searches, to make really relevant searches that they did have at the very beginning that they did over the years cut out because they were too expensive. I think, too expensive in terms of processing. And also because it's just so much easier to give you quantity, Yeah.
And I certainly know from my database days that there are queries that you can run that make the computer do a lot more work. And I can see why they might avoid those.
Over time, we've talked a lot about how to make your own meat. And now here are these big vats, 4-story bioreactors that will produce no-kill meat, 13,000 tons of chicken and beef per year. Tell us about it.
It's what people are calling a game changer in terms of cultivated meat. Now, one of the problems with this whole area is they still don't have a good marketing name for it. Is it no-kill meat? Is it cultivated meat? Is it vat-grown meat? I don't know. And they're also, whatever name they use for it, then the Cattle Growers Association are going to fight that name because they want to have meat as the exclusive name for their product. So, but anyway, that what you call it is a whole other subject. And so they are starting to build the world's largest bioreactor, and they plan to supply tens of thousands of shops and restaurants, and this is going to change the game. It's a U.S. company, Good Meat, and it says that their bioreactors will grow more than 13,000 tons of chicken and beef a year. 13,000 tons is a lot of hamburgers. And it uses cells taken from cell banks or eggs, so the meat will not require the slaughter of any livestock. And there are presently about 170 companies around the world working on culture meat, but Good Meat is the only company that has gained regulatory approval to sell its product to the public, and they began selling cultivated chicken in Singapore. I think we've all heard about that. They started that in December of 2020. And cattle, chicken, and livestock have a huge environmental impact, and the proponents of cultivated meat say they can provide the same taste and feel as conventional meat, but with a far smaller environmental impact. I also predict that in the long term, the costs will be lower, because if you look at the cost to produce something, it is your process cost plus the energy plus your inputs. And growing meat in a tank, you use a lot less water and fertilizer and other chemicals than you do growing it on the hoof. So it's much more efficient. And in the long term, that efficiency, I believe, is going to show up in cost. In the near term, it'll be more expensive. The creators of the culture meats bioreactors, they're making 10 of them, and each of them will have the capacity of 250,000 liters and will stand 4 stories tall. And the U.S. site is planned to be operational in late 2024 and start production at that time. And the cultivated meat matters because it'll let us eat meat without all the harm, without the environmental impact, without bulldozing forests, without the need to tear out the Amazon forest, without the need to slaughter an animal, without the need for antibiotics, without accelerating these animal-borne diseases. And altogether, the challenges are significant, the capital investments are significant, but the market potential is immense. If you looked at the value of the worldwide meat market, it's going to be a number that has a lot of zeros in it. It's a big number, so it's a giant market. And the thing that had limited investment so far was the taste of cultivated meat. But here, one of the big investors who came in said before he agreed to come on, I had to try the meat. I had that first bite and realized that it was simultaneously one of the most unremarkable things and one of the most remarkable things I've ever eaten. It's just meat. And so, anyway, the scale of Good Meat's facilities and investment represents a growing confidence from companies and investors in the commercial potential for cultivated meat. And they are saying further that by 2040, which isn't that long from now, most of the meat eaten on the planet will not come from slaughtered animals.
Any thoughts?
You already have products in the United States like artificial meat is called Beyond Burger, Beyond Meat,
Right.
Beyond Sausage.
The
And
plant-based stuff.
yeah, it's pretty good actually.
Right.
So they're going to have to compete against those products.
Of course.
Richard, what are the inputs for this?
We have water and whatever it takes to make a cell grow. So it's got to have some food. I don't know what the nutrients are.
So what you have really is meat.
Right.
It's not plant-based, it's real meat.
It's real meat. I remember a science fiction story a long time ago where they had growing in the kitchen something they call Chicken Little. And when you wanted to have your dinner, you would just slice some off a Chicken Little and put it in the pan and cook it.
Sounds like that time is coming. I think the prediction is right that in 20 years, that's what we'll all be eating is cultivated meat. But it's real meat though.
Yes, it's real meat. And if you look at that prediction, then still so much of the land is presently devoted to growing the on the hoof meat, that it's one of the things that will change the equation for land use for the planet. And we think that'll help the climate story.
Climate change. The cattle producing people don't want to hear about us talking about this even.
No, that's right.
A lot of people are negative about meat for a variety of reasons, and you've already discussed them. Will these negative feelings about meat still persist after this? Is there something instinctive about it that people say, no, we can't do that, even if there is no slaughtering?
I'll wait for answers, but I please respond.
I was waiting for your answer, Richard.
Oh, my answer, I've talked since, I'm in the meditation business, and that means that among the people I hang out with, there's a higher percentage of vegetarians than in the general population. And I am not a vegetarian. I've talked to vegetarians about this specific issue, and I so far have not found one of them that have said, this is going to change my life. They're all saying, I'm going to remain a vegetarian. And so there are ethical reasons for being a vegetarian, and there are dietary reasons for being a vegetarian. This one takes the ethical issues out of it, but it leaves the dietary issues. There are also, I think, besides that, there are a big range of emotional issues around it that make it a lot more complicated. So anyway, so far, everyone I've asked has said, no, I'm not going to matter to me.
Richard, one of the dietary issues is toxins. And there are a lot of medical people who say if you do grass-fed meat, for example, instead of the way we do it most of the time, it doesn't have any of the dietary implications.
Right.
But in fact, it's very, very healthy. Some of them would say. So presumably with this kind of thing, there'd be no reason for there to be toxins.
Right. I've read similar kind of analyses that besides toxin, there are other diseases that are carried with meats. And then there is always, when you're talking to vegetarians, one of the things that you will hear about is the effect of the hormones in the meat that the slaughter process happens. And none of that will be here with this cultured meat. So it
I,
had
I, I really am having a hard time picturing what this product is going to look like.
meat.
What? Well, chicken leg? I don't think so. I mean, what am I going to go and buy?
I don't.
All
Well,
going to be ground? Is it?
no.
I mean,
One of the things I know there. I don't have the answer for your question, but I know that they have been working on uh, the what you can think of as presentation to be able to grow a steak that looks like and feels like and tastes like a steak. So they're concerned about the look and feel of the product when you're competing with whole grown muscle meat.
Would it have bones in it?
I was going to say, presumably it's all boneless, right?
Okay, it's going to be boneless unless for extra we can put bones in.
You won't be able to make bean soup with ham.
One other comment on this, that is that we're using meat as a generic term, but there's a huge difference between meat, for example, that you might get in a restaurant in Argentina and one you might get in a restaurant somewhere else. So the taste of meat varies a lot when you can't always use meat as a generic term.
Sure.
Is it going to be as good as the best meat you can get in South America or something else?
Well, also, I know one of the things that they're working on is cell grown fish. And different people have different fish that they desire in different places. So they're working on it to be able to grow the kind of fish in the location that they want. So if you're in the South, they'll grow catfish.
Presumably the nutrition is going to be.
The nutrition is better because, like Fred was talking about, there are toxins and diseases, and we haven't talked about things like mercury in fish and things like that that won't be there because it's grown in a more controlled environment and doesn't absorb those other things. So there's a strong argument that says whatever comes out of this process will be better quality food than you can get naturally.
Richard, moving on to materials, we've talked about wonder materials, next generation wonder materials, but we've always talked about graphene. Now you're talking about graphene. What's that?
Well, I'm glad you figured out how to pronounce it. I kind of thought it would be graphene too. Here, let's just look at a picture. Maybe this will help. On the left are those neat little hexagons, and those are carbon atoms, and that's graphene. And on the right is just one of the 5 different forms of graphene, and there you see, besides the little hexagons, the hexagons, instead of just being adjacent, are joined by these strings of carbon atoms. And if you look at a big picture, you can see a hexagon that's made out of 6 of these triangles and a central hexagon. But that's the general form of graphene. If you look at the images of other graphenes, you have different versions of that same form of the image. What's different between them is the number of carbon atoms between the little hexagons. This has 4 carbon atoms, this has 6 carbon atoms, this has 8, 10, and 12. So these are different patterns that can show up. I can't make it go off of my screen. I don't know what I did. But okay, here we are. Okay. Anyway, so these are different arrangements of the carbon atom, and because of the quantum effects on how these change when you change the pattern of the atoms that generate the quantum effects, they believe that these will introduce a number of new electrical properties. One of the things they see already is graphene is a conductor of electricity. These different forms of graphene still conduct electricity, but differently depending on how you configure it. So they see differences already. And we know carbon forms different forms, some of which we're familiar with. We're familiar with the graphite in the pencils, and the diamonds are another form, and these are just still additional forms of these carbon atoms working together. They had to solve some new problems to be able to make it. They'd worked on making graphene for years and were unsuccessful. And here they were able to use a organic chemical reaction plus heat and pressure and be able to make them and make them reliably. And now that they can make a bunch of it, what they're going to do next is spend some time studying it and figuring out what its properties are. And I expect that there will be a series of articles that I report on in the next coming months about the new wonder properties of graphene instead of the wonder properties of graphene.
Any thoughts? Well, then, moving on to astronomy. Tell us about the Webb telescope, just about ready to explore our solar system.
Now, Daryl, of course, knows all about this. I'm just catching up like I do with the based on these articles. And, the Webb telescope now is going through its final phases of commissioning and working on technical operations of the observatory. And one of the things that they have in fact tested was their ability to observe a moving object. They used tracking of an asteroid to be able to confirm they could do that. And they want to be able to do it because one part of the mission for the Webb, and a part that I didn't know anything about, was their plan to observe this solar system. And in the first year of operation, they are going to have 7% of their time on the Webb will be spent by guys trying to learn more about our solar system, not looking far away, but looking up close, because there still are lots of mysteries up close. And they will spend time looking at the giant planets and Saturn's rings and explore many Kuiper belt objects and do things like analyze the atmosphere of Mars and study the surface of Titan and more. And one of the things that they're excited about is the chance to observe ocean worlds. There's evidence from Hubble that on Jupiter's moon Europa, there are sporadic plumes of water-rich material, and they plan to take high resolution images of Europa to study this. Having the source of water on the moon of Jupiter seems like it could be handy. And they also uh, are going to spend time studying Uranus. And Uranus is a planet that has not been visited by any of the missions, so we're dependent upon our uh, observations to study it, and they're still trying to learn about the chemistry and composition of the upper atmosphere in Uranus. And so it turns out this is going to be a busy year for the planetary observation, and they have been planning this first year of observation for 20 years. And so I think they're going to be ready to go. And one of the things I think that is wonderful about this is almost all of this solar system data will be freely available almost immediately to the international community. So this to me seems like real science where part of the objective is to get the data in as many people's hands as fast as we can so they can figure out what in the heck we're finding out. So,
Any thoughts?
Well, I noticed that 93% is going to be on other things. I wonder if Gerald knows what those are.
Well, it's going to be deep space objects, other galaxies, looking back to the beginning of time,
right,
trying to find how further back than Hubble can we look in
right,
time. So a lot of different things. A lot of this information hasn't been given to the general public about what the actual studies are going to be, but it's starting to come out now.
yes,
And I'm sure in about 1 or 2 months from now, we're gonna see one image that's just gonna wow you.
yes, yes.
And I can't wait to see what that one is. And it probably won't be, something in the solar system.
It's not going to be local.
No, it's going to be far.
Now, one of the things that really struck me reading the article is when they said, we've been planning for 20 years what
Yeah.
to do. And so I think we're going to have a good first year.
Yep, I think so too.
Moving on to biology. What's this about another layer that in the code of life? What's that all about?
Well, I thought I had it figured out last week, but here now there's new stuff this week. So I have to keep trying to understand. And what they have found with a new examination of the way that different tissues read information from genes is they've discovered that there are different reactions in different parts of the body systems to different ways that proteins can be made. We had the wonderful discovery of the DNA double helix with the A, C, T, and G links, the 4 links. Before you can make 4, you make 3. And these 3 letters are called codons. And codons contain the recipe for a single amino acid. And these single amino acids are the basic building blocks of proteins. And when they started to understand how the genetic system worked, they uh, were puzzled because they found the DNA codes use 61 different three-letter codons to produce just 20 amino acids. So there is a bunch of duplication in the system where different codons can be used to generate the same end product. And so they have spent years trying to figure out what is going on with this. And the basic current understanding and what is being taught in biology classes is when you change from one version of the codon to another and it doesn't change the amino acid, it's called a silent mutation, implying that it doesn't matter. But using current technology, they have been able to answer questions about how these different combinations play out. It turns out one of the things when they find some combinations, some codons are common and some codons are real unusual. Some ways to make that amino acid are not usual, and some are the regular way to do it. And so what they decided to do was to kind of zoom in on that and look at the difference in codons with the main codons and the infrequent codons and look through the organs in a body. And what they found was that different organs different tissues seem to have what they're calling a codon bias, which is different frequencies of these different codons in different tissues. And what they found one of the things they found that was interesting is there are two tissues that are very tolerant about these rare codons. Those are in the testes and in the brain. And it looks like in the testes that the testes are designed in a way where it's going to give you the maximum number of genetic variations that are possible. So when we're making our seed making equipment is designed to produce a lot of varieties. It turns out the women's ovaries are very intolerant to all these different varieties. So the ovary is the filter to make sure the men aren't too crazy. You've heard of that, I know. And it also is interesting that the brains are real open to these rare codons. The brains allow more flexibility than others. They think what the deal is that the transcriptions of the genes that have these rare codons, when they make proteins, they don't make proteins as fast. And so it's like using these other codons is a way the biological machinery has to regulate the speed in which processes work and proteins are made. And so because of this, they believe that these codons and the common codons and the rare codons are showing yet another layer in the genetic control of life.
Any thoughts? Well, then we can move on to mindfulness training. Does mindfulness training produce brain change? The research that Richard is referring to here says, nope, short-term mindfulness training doesn't. But Richard thinks that there can be significant mindfulness, I guess, if you make it go on longer. Richard, tell us about it. Are you muted, Richard?
I was muted. It was the button on my microphone that I bumped with my elbow and turned my microphone off. Anyway, there was one study that was done about 20 years ago on mindfulness training where they did brain scans before 8 weeks of mindfulness training and then did brain scans afterwards and found that there were brain areas that were bigger, that had expanded. And they were happy to find this. They had found out in years before that the brain is plastic and continues to change through your lifetime based on how they use it. And they were saying that this is confirmation that mindfulness changes the brain. And they did new research and they use better methodology and more current equipment. And in their new research, they did not find the changes that they found 20 years ago. And so they're saying there's no evidence that mindfulness produces short-term results with the brain. And so that's as far as this study goes. I've studied a lot of the research and brain work that has been done with meditators and long-term meditators. And what I can tell you is they've studied the brains of people with substantial time in meditation, more than 10,000 hours. And though I've been meditating for 35 years, my own calculation for my meditation is 7,000 hours. So I'm not yet to the place where I could even qualify for the testing. And what they found with people with extensive meditation practice was they were able to find differences within their brain and the usual brain. One of the differences they found was with the amygdala, which is in the old brain, sometimes called the lizard brain, and it's the heart of the fight and flight mechanisms with the brain, and it's the place that produces the stress hormones and things like this. And what they find with these long-term meditators is the amygdala has gotten smaller. I've heard some studies describe it as atrophied. And so there is evidence of long-term changes to the brain happening with mindfulness and the kind of meditation technique. You just have to do it for longer than 8 weeks, I think. And so they just haven't studied it enough. The scientist who did this research says that we are still in the early stages of research on the effects of meditation training on the brain, and there's still much to be discovered. And I think that's the case. And anyway, I still recommend it for all the good that does me.
Any thoughts?
I came away with the conclusion that perhaps the benefits of meditation aren't always measurable in stress reduction and in other ways, but I'm not sure that they aren't measurable, but I suspect that some benefits aren't measurable. The other thing that I concluded, and I think the article points this out, is that they say mindfulness works. It just doesn't have to be meditation. It can be other things, other ways
Right.
to do it.
Right.
So,
Well, there's certainly in my mindfulness teaching, I teach that there are lots of ways. Mindfulness is not a specific sitting in a position doing something. It's something that you can take through your life. And the heart of mindfulness is deliberately paying attention. And you
right.
can do that doing a lot of things. You can do it picking your nose.
I noticed that one of the groups, one group was meditators, but there was another group that didn't meditate, but they did something. I can't remember
Some
exactly.
self-care stuff, exercise, and
Yes. And the study concluded that was good too, that you
Right.
could get equal benefits from that as you can from meditation.
right.
At least that's what I concluded.
Well, again, that's what they said. They had 3 control groups: the mindfulness group, the self-care group, and a let's do nothing group. And both of the mindfulness and self-care group showed beneficial changes,
Right.
but the changes that they showed were based on self-reporting rather than brain measurement.
Richard, on to our final story about what are aging clocks? These things that will tell you how long you might live? Is it accurate? What is this?
Well, aging now, the view of aging is it's a lot more than just the number of birthdays that you have clocked. There's a biological age that can be different than your chronological age, and they say the biological age is a better reflection of your actual aging. And uh, but how do you calculate this biological age is not straightforward, and scientists have been trying to figure out how to do it effectively for the last 10 years. And the big idea behind these aging clocks is that they can indicate how much your organs have degraded and predict how many healthy years you have left. And though there are hundreds of these aging clocks that have been developed over the last decade, and the accuracy varies widely, and researchers are still trying to figure out, in fact, what does it mean to be biologically young? And most aging clocks use estimate a person's biological age based on patterns of epigenetic markers, and these are methyl groups that are layered onto the DNA and affect how the genes are expressed. So it turns out part of aging looks like it's a matter of what genes are being expressed now and what genes are not. And the pattern of this methylation across thousands of DNA sites in the body seems to change as we age. And so far, they don't really understand this, but they've observed it. And so most of these aging clocks promise to predict lifespan by estimating how a person's body has aged using these epigenetic markers. And one of the places where people are actually trying to use this now is as a way to be able to test anti-aging interventions like diets or supplements or drugs to see if they can provide evidence that they're making people biologically younger. The problem is that we don't really know yet enough about these clocks to know if they can accurately make these kind of claims. The first epigenetic clock was developed in 2011 by Steve Horvath of the University of California, LA. And in 2013, he developed his specific Horvath clock, which is the best known anti-aging clock, and it's based on the epigenetic changes in 51 different body tissues and types, and he's got an algorithm that he trained to get the results. There are other groups that have similar clocks, but of the hundreds that have been developed, there are only 10, or there are fewer than 10 that are actually being used widely in human studies, and these are mostly being used to assess how diet and lifestyle and other interventions might affect aging. And most clocks are designed to predict biological age, but there is one other clock that Horvath released in 2018, which is designed to tell you how many years you have left. And it's called PhenoAge, and it's better at estimating, or this one is better at estimating biological age than the clocks. I'm trying to find the name of the one that tells you how many years you have left. It's called GrimAge, and it's the best at predicting mortality. And one of the things that shows the kind of problem with using these kind of tests, since we don't know what they mean, here one of the primary researchers used the GrimAge test 2 years ago, and it showed that his chronological age and his biological age were the same. He did the same test a few months ago, and GrimAge has his biological age as 4 years older than his chronological age. So if you believe the test, then his biological age has gotten older by 4 years in the last 2 years, and it means that he's aging faster than he should have, and he doesn't know why, and he doesn't know if it's accurate, and it's the kind of measurement that would frighten you and make you think, what am I doing wrong? And they don't yet know if he's doing anything wrong. And so they have measurements. They don't know what the measurements mean. They don't really know what you're measuring. And also part of the problem is that many of these epigenetic aging clocks are what's called noisy, prone to random error that distorts their results. They're trying to look at these different clocks now and comparing them and figuring out what works and what doesn't work and maybe making a better one. It does look like a promising area, but some work has to be done. And as part of the work, they have to actually figure out what this means and how can you apply this knowledge. Maybe it will be that sometime in the future, our clinical health care checks might include an epigenetic time check along with the blood tests they do every year. We're not ready for it yet, but maybe that's coming.
Any thoughts?
What happens if some of this data get into insurance companies that can figure out whether
That's
are you a
right.
good risk from your point of view?
That's right. That's a big issue. That's also one of the reasons why there are privacy issues about this genetic information that are not trivial.
I was going to ask what use this might be, and I think John just gave us one, or Jonathan.
Certainly, that's right. Well, again, one of the uses that it could be is if I am trying to do something to change my own aging, like there is an anti-aging drug, rapamycin, that I've heard about that's supposed to be beneficial but has some side effects, and having something like this could let me try a treatment and then see if it's giving me beneficial results. So I can see trying to use it to evaluate different treatments on myself.
And when we talk about benefits, a lot of the people these days are talking not merely about how old you can live to,
Right.
but are talking about how you can be healthy
Right.
longer.
Yes.
And a lot of them want to say, I don't necessarily care when I die, but I want to be healthy until I die. And it seems that likely the way to increase how long you will live is by being healthy for longer.
Right. I think you're right.
Well, I think if you have an idea of how limited the rest of your life is going to be, and if you're enjoying yourself fairly good, you might start enjoying yourself a little less because you start to worry.
Could be. Or enjoy it more because,
Yeah, live
eat, drink, and be
to the hill.
merry because tomorrow I'm gonna die.
Yeah, right. But that's only a song. But in reality, I think people would worry.
Right.
I mean, seriously.
Well, again, different people react differently is what I notice.
Absolutely.
And the other thing I notice is that I am not good at all at predicting how people are going to react to anything.
There's been an awful lot about anti-aging and different pills and everything else. Have any people found that some things really work for them?
Well, there's a lady who lives here in Aiheek that I used to see pretty regularly years ago, and I met her again just a few weeks ago. And anyway, she was talking about this Prevagen. I'm not sure if you can actually buy that here, but I know there are a lot of ads on the American television for this as an anti-aging product.
What's it called?
Prevagen.
Graphene.
Prevagen. Yeah, it's prevent aging. I think it's in the shortening of that. Prevagen. Prevagen. I think is the way it's spelled. Anyway, I think it's not cheap to begin with, but people do say that they feel better if they start using it. For one, your memory seems to improve.
Ask your doctor if it's right for you.
But
Well,
the doctors will give
I
you
did-
conservative answers.
Well, I did just that, and my doctor Garcia says, well, can't hurt. So I mean, I don't really know what he said. I mean, can't hurt. I'm sure that it's true, but
Like, I expect there's a lot of truth in some of these, but I remember years ago when I went to my doctor and I was trying to take some supplements, and he said, well, taking supplements is good because now your urine's much more expensive.
yeah, right. Exactly.
That's right.
Yeah.
Anyway, is there anything else on that? If not, we'll say thanks to Richard once again. Thanks to everybody for participating, and we'll see you next week.
Good
Bye
to see
for
you,
now.
Daryl. Good to see you,
Thanks.
Daryl.
Adios.
Thanks, everyone.
Bye,
Okay.
John.